Hi, welcome to this video. In this video, I'm gonna go over a few examples that involves word problems, and all these word problems will require your knowledge on exponential and logarithmic functions. So I hope you guys by now should be familiar with the laws of exponents and the laws of logarithms. Okay, so let's get started. So we have a freshly baked cake, and we are taking the cake out from the oven, and this equation that we see here, that equation tells us the temperature of the cake given a certain time, right? Given a certain time. So time is in minutes, and the the temperature is in Celsius. So for part A, what is the temperature of the cake when it is removed from the oven? So we just took it out from the oven. What's the time going to be then? What is the time? Oops. What is the time when I just removed the cake out? The time is going to be 0. Make sense? Right? So which means all I have to do is substitute the time with a 0 back into my equation, and that will give me my temperature. So e to the power of 0 gives us 1. So I have 85 degrees Celsius. Not too bad, right? Okay, so let's look at part B. How long would it take for the cake to reach 25 degrees Celsius? So in part B, instead of finding the temperature, they gave us the temperature, and the temperature is equal to 25. Now they want us to find the time, so which I will have to use my equation, and now I need to solve for t, which is in the exponent. I need to somehow bring it down, so which means I'm gonna involve logarithms, right? Logarithms. I'm going to L in left, L in my right, and I will have, on the left hand side, I'm just going to have L in 25. On the right hand side, I'm going to have, in fact, I'm not going to do all this, because what I could do is I'm going to divide 85 to both sides. Right? So that goes away. 25 over 85, that would be 5, and this is 17. So I have e to the power of negative 0.1 t is equal to 5 over 17. And again, because I'm trying to solve for that t there, I'm going to take the natural log of the left. Why do I go with natural log? It's so that I can cancel them out, right? They're inverse of each other. So I will get negative 0.1 t is equal to ln of 5 over 17. And my t is simply equal to ln of 5 over 17 divided by negative 0.1. And if I put that in my calculator, I should get, just give me 1 second here. This is 5 over 17, and then I have negative 0.1. My t will be approximately 12.2, and then for the time, in this case, it will be in minutes. So after, if I take the cake out, and after 12.2 minutes, my cake will be approximately 25 degrees Celsius. Actually, let me rephrase that. I should say that when I take the cake out, after approximately 12.2 minutes, my cake will reach at 25 degrees Celsius. Okay, let's do the next one. Again, please pause the video if you need to, and try to understand what the question is asking us to do. Alright, so let's take a look at here. So we have population. My population in this case is A of t, right? A of t represents the population in a city, and this is in thousands, yeah? The whatever population we have here is given in thousands. So let's say if my A of t is equal to 1, that means 1,000 people, okay? If my A of t is equal to, say, 25, that means 25,000 people, okay? Don't forget the unit. The units, sometimes they are important, okay? Sometimes they give us information where we need to be careful with them, okay? So the A of t over here tells me my population, and this t represents the number of years after 2010. The t is the number of years after 2010. So we can kind of think about this as with maybe a group of scientists. They're trying to predict population. They're doing a research on population, and they start in the year of 2010. So if you look at question number A, what was the population in 2010? So the t represents number of years after 2010. But in 2010, it's after what year? It's after 0 year, right? So my t is equal to 0, which this is 2010. Okay, so which is because the t is number of years after 2010. So after 0 years, which means it's in the year of 2010, and they want us to find the population. So we just substitute the 0 in the equation. 0.02 times the 0, that gives me a 1. So I will have 30. But that's not we don't have 30 people. We have 30,000 people, yeah? Because that's the unit for my A of t, 30,000 people. Make sure you put that down, because this is going to worth as 1 accuracy point. Even though this is correct, you correctly solved the equation, but you did not take into consideration of the details, okay, and that's going to cost you. All right, for part B, let's see what we have to do. What percentage is the population of the city increasing every year? So now I know that when my t is equal to 0, I had 30,000 people. When my t is equal to 1, that means 2011. Right? Let's find out how many people do we have. So that would be a to the a of 1. So it's 30e 0.02 times the 1, which is 30e 0.02. Okay, what I'm going to do now is to compare these two values. Okay, I started out with 30, and after 1 year, I have 30 times e to the power of 0.02. So so if I want to find the percentage, I need to find how much did it increase, which is the new value minus the old value divided by the old value, right? Times 100%. And if you put that in your calculator, I will get approximately 2.02%. Okay, so this is by comparing the initial population with the population after 1 year. Why don't we compare the population after 2 years? Right. So we're going to compare the population after 2 years with the population after 1 year. Okay, so I'm going to compare A of 2. Let me just do that here. I'm going to compare A of 2 versus A of 1. All right, so let's find out what's A of 2. So A of 2 is equal to 30e, and then 0.02 times the 2, which is 30e 0.04. So again, if I want to find the percentage increase compared to the first year, because they're asking us each year, right? Each year. So I'm comparing the population after 2 years with the population after 1 year. So that would be 30, the new population, minus the old population, which is after 1 year, divided by the old population. And then times 100% as well. So that's going to give me, if you put that in your calculator, let's see what happens, yeah? You will see that it is also approximately 2.02%. In fact, they are the same, not because I rounded them up, because they are the same. Okay, they are the same, and they are increasing because of this 0.02, right? Because of that 0.02. So if you want to try further, I think it would be interesting to compare the third year versus the second year, and you should see that the percentage increase is also equal to 2.02%. All right, so give that a try on your own, and think about why is this happening. Yeah. But anyways, let's continue with this question. So we got the answer for part B already. Let's look at part C. What will the population be in 2020? So in 2020, that's how many years after 2010? That's 10 years after 2010. So that's when my t is equal to 10. T is equal to 10. So if they want to find the population, I'll have to put the 10 in there. But that becomes 30 times e to the power of 0.02 times the 10. And again, you put that in your calculator, you will get this. You will get around 66.6 thousand people. Yeah? 36.6 thousand people. Okay. For part D. Part D is they want us to find the time. When will the city reach 60,000 people? So because I'm running out of space, I'm going to delete this part. Alright. Please feel free to rewind if you need to. Oops. Okay. Now. So for part D, we need to find the time, knowing that my population is 60,000. But this 60,000, because the population that I get out of my A of t is going to be in thousands, which means my A of t here, it is not 60,000, okay? That's not right, because my A of t is already in thousands. So I can remove the three zeros at the back. Does that make sense? So please be careful with the details, okay? Because sometimes it's the details that's gonna get you. Because if you had 60,000 here, that actually means 60,000 thousand, okay? 60,000 thousand, which is not true, obviously, right? So please be careful with the details, okay? So A of t is equal to 60, and they want us to find the time, so we can just substitute the equation back in there, and then we just find the time there. So if I divide both sides by 60, I'll get 2 is equal to e to the power of 0.02t, and then I can L in the left, L in the right. I'll get that cancels out. I'll get 0.02 t is equal to ln2. So my t is equal to ln2 divided by 0.02, which is going to be approximately, let me put that in your calculator. Okay, it will be approximately 34.7. All right, so how long? When will it be? It's either, you can either say after 34.7 years, or you can say in the year of 2000. So this is 2010 plus 34.7. That gives us 2044.7. So maybe something like in the year of 2045. Okay? That's it for now. If you guys are ready, then please proceed to the next video where I will show you guys where there will be the word problems I have in the upcoming videos. They won't give you equations. They won't give that to you. Okay, they won't give it to you. They won't give this to you either. They'll give you a bunch of information, and you need to come out with the equation on your own. It sounds intimidating, but don't worry, you guys will be fine. I'll see you guys in the next video. Bye bye.